Hi Year 12. So, before we start the lesson, I want you to think about what the focus of today's lesson might be, and I'd like you to put these organisms into two groups, please. I'll give yourselves a minute or so to think about and put them into two groups. Okay, hopefully you had a think about them, and hopefully none of you said this. Now, hopefully you put them into two groups that you might have called cold-blooded or warm-blooded, but maybe you thought about them more in terms of whether they maintain their body temperature or they don't. So hopefully you chose things like the tiger and the chicken and the seal as organisms that maintain their body temperature, which are called endotherms, and then ladybirds, I think these are fake ladybirds actually, crab, fish, bees, and crocodiles. In fact, any other organism that's not a mammal or a bird, any other animal that's not a mammal or a bird, they do not maintain their body temperature using their internal heat energy sources. They are called ectotherms. So our focus today is to look at temperature regulation in ectotherms. So we need to think about why temperature regulation is important, and then look at the difference between them, and look at the behavioural and physiological responses that ectotherms show, and apply your understanding, which you can answer some questions on later on. So first thing I'd like to think about is, why is it necessary for animals to maintain their body temperature, and why do you think it's wrong to talk about cold-blooded and warm-blooded animals? Have a think for a minute. So the key thing is that control of body temperature is important because of enzyme activity. Okay, remember, metabolism, all the chemical reactions that are going on inside an organism is affected by temperature, affects the enzyme activity because of the kinetic energy and the number of collisions and enzyme substrate complexes, all that sort of stuff we thought about when we did foundation biology. So organisms need to maintain a body temperature at which their enzymes can function, and therefore they can do metabolic processes. And all the metabolic processes in the body, not just respiration, but all the other processes, will be affected by temperature. It's wrong to talk about organisms being cold-blooded, warm-blooded, because of the impact of the environment on what are called ectotherms. Okay, so I want you to have a think about the next slide and see what you can come up with. Okay, so here's a graph of ambient temperature, in other words, the temperature of the surroundings, and the body temperature of the organism. I would like you to just sketch that out quickly, and what would the difference be in core body temperature of, say, a cat and a snake? So a cat being a mammal, so an endotherm, and a snake being a reptile, and therefore being an ectotherm. What would that look like? What would that graph look like as we change the outside external temperature? Give yourself a minute or so. Okay, so let's have a reveal. Right, so what we see here, if we look at this, we can see that the temperature for, I've got a bobcat here, so a mammal, doesn't really change very much as we increase the environmental temperature. Yes, it gets a little bit warmer when the environment around it's a bit warmer, or when it gets very cold, its core body temperature will fall a little bit. But for us, it's fairly constant over that range of temperatures, and between sort of 5 and 40 degrees C, the temperatures you might expect to be a mammal to be able to cope with. But if we look at the snake, basically we've got almost pretty much a linear graph here. Of the snake eating a rat. You can see that whatever the temperature of the environment is, the temperature of the snake tends to be exactly the same. And that's the key thing about ectotherms, is their core body temperature tends to be the temperature of the surroundings. We can see here why it's not correct to talk about it being a cold-blooded organism, because if the environmental temperature gets very high, or they're exposed to high temperatures, their core body temperature, and therefore their blood, will be the same. Will be that temperature and be very warm. So they can be as warm, if not warmer, than an endotherm. Another thing to think about is it seems to imply that body temperature in ectotherms is always whatever the environmental temperature is, but that's not to say, and that is basically true, but it's not to say they don't do things to try and regulate their body temperature. Otherwise, what we're going to talk about in the rest of the lesson makes no sense. Okay, so they will do things to try and maintain their body temperature at a reasonable temperature, because otherwise they cannot be metabolically active quite often. Okay, or it will affect their metabolic activity. So, what is an ectotherm? So, ectotherms are sometimes called poikilothermic. So their body temperature changes with fluctuations in the environmental temperature, and they're not able. The key thing is they're not able to increase their respiration rate to generate heat internally like we do, like mammals and birds. Okay, so when they do more respiration, though, they will release more heat energy. So, for example, insects flying, very metabolically active, their body temperature will go up a lot more because of the heat generated by the extra respiration going on. So we've got to be wary of saying, well, respiration doesn't change rate, it doesn't release heat. It does. It's just they don't have a system for going, my body temperature is colder than it should be, I'll increase my rate of respiration, or vice versa. Okay, they tend to change their temperature, their body temperature, and get to a warmer temperature by absorbing heat energy from the surroundings, so basking in the sun, and we'll look at examples of that. So their behavioural adaptations are really important in how they either absorb or lose heat energy, but they do have some of them do also have physiological adaptations to allow them to regulate their body temperature as well, and structural adaptations too. So let's just remind ourselves about how organisms gain and lose heat energy. So have a think, how do organisms gain heat? How do organisms lose heat to the surroundings? So how do they gain heat from the surroundings or from themselves, or lose heat to the environment? Okay, maybe think about your physics. Pause the video for a minute, have a think, what mechanisms can you come up with? So, key things, we've already mentioned it. Did you get heat from respiration? Respiration will release heat energy, so it will add to the heat of the organism. Thinking about your physics, did you get conduction of heat from the surroundings? So if you sit on something warm, so like for example, you know that in the winter when you're cold, coming in from getting the train or the bus or whatever, you can often go and sit on the radiator so you can absorb heat from the radiator by conduction. It's conducting into you. Now I can talk to you about why that's not necessarily a sensible thing to do in terms of continually warming up your body, but we'll come to that when we do endotherms maybe. Convection, so heat moving around. So if you're near a radiator that's warming the air and the air is convecting around you, you can absorb that heat convecting towards you. And radiation, so remember anything that's hotter than you are will be radiating, or is hotter than the surroundings, will be radiating heat out into the surroundings. So you actually sitting in your room at home or wherever you are probably warming the environment, so actually you're losing heat by radiation. But if you're sat out in the garden and the sun's out, you will be absorbing that heat radiation coming from the sun. That's what can make you feel very hot very quickly. Whereas losing heat, evaporation, sweating, panting, okay, having wet clothes on, the water evaporating, taking that heat energy. Remember, water has a high latent heat of vaporization, so it takes and specific heat capacity, so it takes lots of energy to heat it up and lots of energy to make it change state, and that will take that heat energy from you, so it cools you down to removing heat. Conducting to the surroundings, so if you sit on something cold, you will lose heat to the surroundings because you will be warmer than the surface and you conduct heat into it. You sitting on your chair, you are conducting heat into your chair. It's probably not making you feel very cold because the chair is insulated, so the heat you conduct into it doesn't dissipate very quickly, doesn't conduct away quickly. But if you touch a metal leg, you can actually do that. If you've got metal legs on your table or chair and you touch those, the table is the same temperature as the room. But when you touch it, it feels cold because it's conducting heat away from you. Okay, taking that heat away from your skin, so it's making your skin cooler. Okay, convection to the surroundings, so you're heating the air around you, and that air is convecting away, so it's removing heat from you, and radiating heat to the surroundings. So you are constantly losing heat to the surroundings by radiation. As long as you are in an area that is the temperature is lower than your body temperature, you'll be losing heat by radiation. Our body temperature doesn't cool down because we are maintaining it, because we're endotherms, but you are constantly losing heat energy to the surroundings. So make sure you're really confident and clear on these ideas, because it really affects all of the rest of this work on temperature control. So maybe make a couple of notes on that before you move on, and pause the video again. I haven't got a little pause symbol again. Okay, so if you've got a bit of plasticine or a bit of blue tack, you could have a go at the next little slide. Okay, so try and make a little model of an ectotherm and think about how they might behave in the following scenario. So first thing in the morning, how might an organism change its shape, change its position? Where is it first thing in the morning? What does it need to do first thing in the morning? What's its body temperature like first thing in the morning? Right in the middle of the day, what's the issue now in terms of body temperature? Okay, how might it respond? Remember, the whole point is to try and regulate your body temperature, keep it within a certain limit so you can be metabolically active. Got a horned toad here. You can see that he's flattened himself out against the surface there. Why has he done that? You can see this reptile here of some sort, don't actually know what it is, it's actually done a couple of things that sort of seem counterintuitive, but he's actually lifted himself off the ground, he's climbed onto a tree, got his mouth open, he's gaping, but actually he's also got this big flap of skin here. Sorry about the stupid internet links popping up. He's got this big flap of skin here. What do you think that's there for? Okay. Have a think, have a play. And then we'll look at a table of some ideas. Next slide. Okay, so here's a load of things that organisms might do. Okay, have a think about each of them. How is it going to help? Did you come up with a model that, or put it anywhere to make it look like this? Okay, have a think. What would these be? Can you complete this table? Maybe draw it out and spend a good few minutes drawing it out, and then see what you can fill in. So, key things here: if you already expose your body to the sun, it's like sunbathing, basking out in the sun. Okay, exposing as much of your body as you can to the sun. Maybe with that reptile with the big flap of skin, opening that flap of skin up to increase the exposure to the sun. That means you're going to absorb more heat from radiation. Okay, more heat from radiation there. Similarly, if you orientate your body into the sun, so your flank, your side is exposed, you're going to be able to absorb more heat energy, increase your surface area from radiation. But equally, when it gets hot, you can orientate yourself so maybe just your head or your tail end is pointing towards the sun. If you've got a long, thin body, you point the narrower end towards the sun, you're going to absorb less heat energy from radiation. Lots of animals like lizards will do things to get their bodies away from the ground. So during the beginning of the day, they might lay out on a rock because the rocks will be warmed up by the sun and they can absorb heat by conduction, and then warm up and become more metabolically active and ready for the day to go on hunting or escape from predators more quickly, etc. But when it gets really hot, they don't want to be absorbing heat by conduction, so they raise themselves up. So you might have seen like David Attenborough shows where the lizard's sort of doing that sort of two-legged stand or raising his belly up off the ground. So reducing heat gain from conduction. There's lots of brilliant videos on YouTube you can have a look at. Some organisms alter their body shape. So I showed you that horned lizard or horned toad. So you can change your body shape during the day. So at the beginning of the day, you flatten yourself out and spread yourself out onto the rock. So you've got as much surface as you can squodged out onto the rock. And also a bigger surface area facing up to the sun. You're going to absorb more heat energy, but then during the middle of the day when it's hotter, you make yourself rounder to reduce your surface area to volume ratio so that you reduce your heat gain. And maybe at night you stay that round shape to reduce heat loss, because remember, surface area to volume ratio affects heat gain and heat loss sort of in a similar way. Okay, so you've got more surface area to the sun. Changing the heat absorption also by conduction from the rocks, depending on which way your body shape has changed. Hiding in a burrow, when would you do that? Well, maybe you might do that, or hide in a crevice in a rock or something like that to get out of the sun when it's very hot. So reducing heat absorption by radiation, so behavioural adaptation here. Maybe it might actually be a good idea to be in a burrow at night time, because that will be insulating. The air's not moving around, so insulating and keep you warmer, so that when you do wake up in the morning, your core body temperature hasn't fallen as low. Okay, so remember, if your core body temperature falls lower, all your enzyme reactions get slower, and therefore your metabolic rate is low, and therefore you can't be as active, and that's difficult. And what you need to be is when you want to be active, you need to be able to move about. So you don't want to have a low metabolic rate when you want to be active. So trying to maintain that core temperature better is a good idea. All right, keep it more stable. Yes, you are whatever the temperature of the environment is, because you're an ectotherm, but if you can go into a place where the temperature doesn't change very much, or it doesn't cool down as much overnight, that is a benefit. Increasing breathing movements and gaping, both of these are similar. These are temperature loss increases, if you like, because you're going to increase evaporation, so you lose more heat energy. Okay, so locusts do this. They're going to get hot, they breathe more, so the water in the tracheal fluid, remember, in their spirit down at the end of the tracheoles, evaporates more because you've got more water, more air movement in and out of the trachea. And gaping is a little bit like panting in dogs. They're just exposing the damp surface of their mouths, so more water evaporates to help reduce heat loss. Similarly, if you climb up a tree or climb up a plant or something like that, you're getting yourself off the hot ground, so you're reducing absorption from conduction from the hot ground. It also tends to be cooler up in a tree because of transpiration, the evaporation of water in the tree, and you've also got shade, so you're going to be absorbing less heat energy from radiation from the sun. Okay, so loads of things you can be talking about. So when you're thinking about ectotherms, you're going to be thinking about how do they need to gain heat, do they need to lose heat, are they doing something to reduce that heat loss or increase the heat loss? What is it they are doing? And later on you're going to be having a look at some questions that are going to get you to think about this. So this table might be useful for you when you get onto those questions. Okay, so pros and cons of the ectothermic life then. So can you come up with a list of pros and cons of being an ectotherm, and make sure you can explain them. Okay, think about some of these ideas about food, respiration, activity. Give yourself a couple of minutes, write down 2 or 3 bullet points for pros and cons of being a ectotherm. Okay, so what's the advantage then? Well, the big advantage of being an ectotherm is you're not using energy to maintain your core body temperature. So that means a much lower proportion of the energy you consume in your food is used in respiration. So that is a real advantage, because it means you've got to find less food, and actually you can often survive for long periods without eating anything at all. Okay, and it makes you more efficient in terms of growth. And actually, if you're thinking about food production for humans and using animals just for us and eating and getting protein, we probably ought to be trying to farm ectotherms rather than all the endotherms that we farm. You think about sheep and cows and chickens, they're all endotherms. Huge proportion of our energy that we feed to these organisms is just wasted in respiration because they're keeping their own bodies warm. Okay, whereas ectotherms, a much greater percentage of the energy that they consume will end up being used for growth. So they're much more efficient in that respect, so they don't have to move about as much. But there are downsides to this, because when it's cold, your body is cold, and therefore you have a lower rate of enzyme activity, so a lower rate of respiration, less energy released, less metabolism, all your other chemical reactions in your cells, so you're less active. So you've got much less active in cooler temperatures, which means you're actually at risk of being eaten by something else that is active. Something can come along and just snaffle you off the tree where you might be dormant, or get you in your burrow wherever it is, because you're in sort of torpor because you're so cold. Okay, and a mammal that's still active when it's cooler can come and grab you or whatever it is. Okay, and obviously there's a seasonal effect here. Most ectotherms do become dormant during the winter seasons because it's just too cold. Okay, that's not to say that endotherms don't do that as well. We've got endotherms that hibernate, or they migrate somewhere warmer. Okay, so but you do have to have sufficient energy source. So even though you're dormant, you're not doing nothing. So you're sitting there not able to move around very much, but you've still got some respiration going on. So you do have to have enough energy to survive. So let's have a start thinking about some data and then look at some questions. So next slide is some data to look at. So here we've got a graph of metabolic activity, a rate of oxygen consumption in centimetres cubed per minute. And here's the graph of the data. So what I'd like you to do, describe the effect and explain the reasons for the change and the benefit to the organism. Give yourself 4 minutes. So hopefully you got, as the temperature goes up, you can see the metabolic rate increases, and actually it's not linear, is it? Okay, it's almost it's more than exponential. It's more than doubling every 10 degrees C rise. If you remember from our foundation topic, you have the Q10 theory for enzymes, that if you increase the temperature by 10 degrees C, the rate should double. Now it's almost doing it, but it's more than doubling actually. And 20 to 30 is 10 degrees, 9 doubled will be 18, it's going to 24. 3.8 is nearly 4. So that should be 8, but it's more than that. So it's more than doubling with every 10 degrees C rise, apart from between 0 and 10. So we've not quite got our Q10 being shown here, but it's something worth thinking about when you're doing descriptions. What's the general pattern? Could we have put some data in here or work out what's happening in terms of doubling, tripling, halving, whatever it is? So what's the explanation? Well, we've already talked about it loads. Enzyme controlling respiration have greater kinetic energy, so we've got more collisions of the enzymes with the enzyme active site with substrates in respiration, so increased enzyme substrate complex formation, which means more respiration, more energy can be released, so greater activity of the organism when it's warmer. Okay, so hopefully you had some of those ideas. You must use that term kinetic energy, not just more energy. You must be talking about collision rate and enzyme substrate complex formation. We've got no evidence here of denaturing. I suppose if we increase the temperature more and more, we would get our downward curve again because of denaturing your enzymes, but it's not shown here. Okay, so lots of little links now, and as we go through our Year 13 content, you'll start to see loads and loads of links into content you have studied in Year 12, and you must remember the Year 12 content. It's really important. Okay, you've got a worksheet associated with this lesson. There's 6 questions in the worksheet. Choose 2 of them, so there's like low, bronze, silver, gold level. Okay, gold's harder and more application based. Bronze is more recall of knowledge. Choose a couple of them to have a go at. Challenge yourself if you want to. There's a couple of hints on the end of the question. There's also on the next slide there are some hints as well, okay, which are here. Okay, so hopefully you found that useful. When you've had a go at the questions, just submit them and I can have a look at them. Thank you.